array-based sequence. The title is somehow a bit it's not common because we know about array, but now it is a array-based sequence. So in this section, I would like to explain about the Python sequence classes and what are the types of operations and how we can figure out a growable array. Python sequence classes, as you might know, there are some definition about the sequences. Like we can use list, we can use tuple, we can use other data structure like string. So those are the built-in types. We call it the built-in types because Python already provided to us. And each of this sequence, it supports indexing. You know the indexing, it gives you like index 0, index 1, index 2 to access the individual element of a sequence. And we use the A with the square bracket I to indicate that we want to access the index I. Actually, each of those types is this list, tuple, string. They use the array to represent the sequence. An array is a set of memory location that can be addressed using consecutive index. Consecutive indices, it means we have the index 0 and then 1 and then 2 and next and so on. In which in Python the index starts with 0. Many programming languages, they start the array index with 0, but some of them starts with 1. So you need to look at the programming language policy. When they use 1, of course you need to follow that policy. So there is kind of array you can see with the primitive object. What we call the primitive object is the list, tuple, string, or you can refer to an object. So if it is a primitive element, you can say that, okay, let's suppose I have the index 0 is 1 character, index 1 is 1 character, index 2 is 1 character. We call this is primitive elements. So every index have 1 number, or every index have 1 element. And we can get this one as a compact array. So the compact array, usually it starts on the primitive elements. But an array can also store references to object. If you have class, if you still remember class students, when you have a class name, you make your def init and blah blah blah. When you want to make one object, you will create like a name. What is the object name? Let's suppose S1 is the students, and let's suppose this is the half. For example, because this is an object. This is an object of one class, and you can create another object S2. You can create another object S3, and so on. So you can put this object into index 0. You can put the second object into index 1. So the array actually can also space to save object. Maybe in this example, I want to save an object about the person Rin. I want to save an object about the person Joseph, and etc. So if you have this object S1, last time you learned that, for example, we have two parameters. S1 is a student's with, for example, the name and let's say the location, the city, and then, for example, the age, for example, 25. Okay. Now we can put this object S1 in the index here. So it can be also the alternative to reference of an object. The compact array, we call it compact array. It is the module in Python, we call it as an array. That module defines a class, and the class name is an array, providing compact storage for arrays of primitive data type. The primitive data type means you can use, for example, only one kind of data type. Here, let's say I want to specify only for integer. Then all the elements here will be integer values. If you want to specify this one to float, you can have f, and then all the elements will be float values. The constructor for the array class requires a type code as a first parameter. So this is the type code. This is a character that designates the type of data that will be stored in the array. So if it is I, then we have integer. If it is f, it will be float, and so on. In this case, I would like to call array, which is a class in Python, and we can put the parenthesis, and we define the type code, and then we define the data, and we put all of them into one variable. So there are many type codes. You can use B, it is a signed character. Big B, it is unsigned character. U, Unicode character. H, signed short integer. H, big H, unsigned short integer, and so on. So this is the number of bytes. It means the size when you define the numbers or the characters. Okay, let's see in the example. I give the code IPYNB in the E class. So you can refer to that file. Once you download the file, put the file into your Jupyter Notebook environment, and you can see the code. Okay. So I already have this code, so you can take a look on this one. When you have a list, okay, what is a list? Actually, when you are using list, you can put any data type. You can have integer, you can have float, you can have string, and you can put all of them in the list. Okay. So you can see that the 1, 3,14 circle, any data type can be in one list. And let's suppose I want to check the index 1. Yeah, you can have the value of the data in the index 1. If I want to have a tuple. So I have the 1, 2, 5 square. Yeah, this is the same. I can also have the value 1, 2, 5 square. And if I want to check for every of the element, I can also get the value. And if I have a string like this triangle, and I want to split each of these character into a list, then you can just use list, and then you can split this one into character for each of the element. Let's say if I want to make like L1 for this one, then you can have L1, and then you can have, let's say, L1 index 2. Okay. Then you can have the character I. Or you can put the same data type like this one, red, blue, and green. This is the example that we learned in the first part of the Python. What we are going to do with array is actually with the function or the class array that is a built-in class in Python. And we want to define the array with only numbers. So you can see here, now I have primes, and you want to have the primes, and we have this result. This result shows that it is an array, and the array is a dedicated array for integer data type, and this is all the elements. And if you want to access, for example, index 2, you can also access the numbers. Whenever you use the list, you can append. Do you know append? Yeah, we want to add some data or elements. So if I append, okay, I didn't run this. Let's say I want to run, I want to add yellow. Then every data will be added at the end. Or if I want to remove, when I remove this one, I specify that I want to remove the element, and the element is blue. Then blue will be removed from the data. And if I want to, let's say, insert a value, and I want to insert it into the index 1, I can use insert index 1 and specify what is the value that you want to insert. And you will get like this result. So this idea, let's get back to this one. When you have like this code, of course, if you refer to the code that I gave in the Jupyter notebook, you can see that the import array is using the Python function. This is array, and I want to use it as ARR. It means I want to make it short, because if I type array, it might be too long. So I can make it short as ARR. And I can call the array, and then I want to specify it with D. The data type is 1.1, 3.5, and 4.5. So if I print, the result will be something like this. So what is D? Okay, you can see that D refers to float, and yeah, the number of bytes is very high. It means the range of the values is very big. So the second example, we still use the same import array as ARR, and then we have the array I2, 4, 6, 8. So this is integer. All the elements will be integer. And I want to check what is the first element. So I just write the A0. I want to know the second element, A index 1. And I want to know the last element. So the last element, you don't need to find the length of the array, but you can just define -1. So when you define -1, Python can understand that you want to see the last elements. So the output will be like this one. The first element is 2, the second element is 4, and the last element is 8. If you refer to the code that I gave to you here, you know that yellow is the last element, so the data 2 minus 1, you will get yellow. Okay. What about if I want to know the data 2 minus 2? So this is the second last element. It will be from the last and then move to the starting of the element. You can also have the array with slice. You can, now I would like to teach you how to read the codes without the Jupyter Notebook, because there might be some problems like this one in your exam. So let's say if I have this Python code with slicing arrays. So I'm going to use the array, and I'm using this variable number list, and those are the elements. And I'm making one variable numbers array, and this numbers array is I, which is integer, and then I have the number list. So the number list is this one. If I want to see the element 2 until 5, actually, sorry, this is not element 2 until 5, but it is from the index 2, index 3, index 4. Okay, means index 2, index 3, index 4. Even though it is until 5, but we know that we want to go until n minus 1. Okay, so it means 2, 3, and 4. 5 will not be included. If we want to have -5, it means the beginning elements until the 4th, or -5 elements from the list. So we still have the column to represent this one. If we want to have the starting index until the end, so we have 5 column, and it means the 6th element until the end. Or if you want to get all the elements, you can just put numbers array with the square bracket, and then we put empty on the starting and empty on the stopping. So it will be printing all the elements. So I give you this out. You can check later on your Jupyter notebook. And if you want to change or you want to add some elements, yeah, as I mentioned to you before, yeah, you can have like append, remove. If it is using list, okay. If you are using numbers like this one, then yeah, you can just do like this one. If you want to change the first element, numbers element 0, you want to change it with 0. So the original numbers is this one, 1, 2, 3, 5, 7, 10, and I want to change this one into 0. And I can just dedicate it. There, I'm just assigning the index 0, and then give the number 0 as the value. So the result will be like this one. If you want to change the element from the third element to the fifth element, so you can define this one. I'm going to change from the index 2, 3, and 4, and the array will be this one, 4, 6, 8. So the value will be changing. Okay. So the value will be changing according to this 4, 6, 8 on the particular index. So you can use this kind of concept in the array. Yeah, append. We can also use append in the array. Let's say I have the array, the initial array is 1, 2, 3. If I use append, it means I will add one element. How about if I use extend? In the append, yeah, we usually use this one to only add one element. But if you use extend, it is more about the iteration. So you can have more than one element. So if you append 1, then the result will be 1, 2, 3, 4. If you append 3, you can use extend, and there will be 3 more elements. When you want to remove the array, you can use delete. Yeah, in this case, I have an array. Here is 1, 2, 3, 3, 4. Okay. And I want to remove the third element. I want to remove this one. Then I can just say del. Del means delete. And then I have number index 2. So I would like to remove the third element. Or if I want to delete all the numbers, so I want to delete all the elements, then you can just put delete and mention the variable name. Of course, after you delete this one, you cannot print because the variable has been deleted. So this will be the error message. Okay. Yeah, that's the basic array and operations in the array. Now we want to check this kind of operation according to the analysis. What you already saw on the previous example, we can insert object into the index I. And the example that I show you in the Jupyter notebook, we can use insert. Insert in index, for example, 1, and then what you want to insert, for example, yellow. Then I would like to insert the yellow in the index 1. But there is one issue. When you want to insert into the index 1, we need to make room for the new element by shifting forward the n minus I elements. Okay, for example, I have already 1, 2, 3, 4. Okay. So if I want to insert here, what happened? I need to shift this one. I need to shift this one to this one. I need to shift this one to this one, and then I can insert a new element here. That's the mechanism. Then I can say that the worst case, when I equals to 0, it means I want to add in the beginning. If I add in the beginning, then it will take on times because it will go for all the elements. So all the elements will be shifted. So for example, like this one, I have the I is the index, and then n is the number of the elements in the array. And if I want to insert in I, then I need to shift all the remaining elements. We call this is the n minus I element. So the object O will be added in this position. How about if we remove? When we remove the index I, let's suppose we have removed I. When we have removed I, it means we delete the index I, and we need to fill the hole left by the removed element by shifting back the n minus I minus 1 elements. So which is the I plus 1 until A minus 1. Because this is also, again, in the worst case, if I remove the index 0, what happened? We need to shift all to the beginning. So let's suppose I want to remove the index I. I want to remove this O. When I delete this one, then all these things will be shifted. And after we shift it, then this will be the new array. If I equals to 0, it means it is the element in the first element, then the worst case will take on time. All the elements will be shifted. Therefore, we can have the analysis. When you implement in array, you will have the operation add and remove, and remove, and the complexity will be on when you have the additional, in the worst case, because you will have n elements. And if you remove, you will also have on, because in the worst case, you will have n elements. In this section, I would like to give you one more complexity. We call it the space complexity. What is space complexity? So the space complexity means I want to know how big the size when you have the elements. Because I have n elements, then I can say that the complexity of the space is On. And we want to just do the indexing for every element, then it will take only one time, because whenever I set the index 5, then it's only one operation. So it is a constant. And for the add and remove, it runs for n times in the first case. When you do the add operation, what happens when the array is full? So instead of throwing an exception, we can replace the array with a larger one. So as I mentioned to you before, we have two kind of functions. The first is append and the other is extend. If append, yeah, you can just add one element, but if you extend, it is an iteration to add more than one element. Okay, you can have more than one element. Now, if you have a larger array, how can you do it? We call it, this is the growable array. The growable array means when you have an array, let's suppose I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Okay. Now, I want to add more elements. So I need to prepare some space. But how many space do I need to prepare? We need to understand the growable array, because in this kind of problems, you still need to make a kind of strategy. How many elements you want to add, and how many elements you need to prepare. In an add O, so it means I want to add an object. And if I do not give any index, without an index, we could always add at the end. So that's the same what I explained on append. We will add always at the end of the list. And when the array is full, we replace the array with a larger one. How large should the new array be? This will be a question. So for example, you can see here. Now I have the data 2, 1, 2, 3, 4. When I check this one, length of data 2 is 4. Now, if I have a new data again, data 2 dot append, let's say brown. Then when I check the data 2 with the length, then it becomes 6. Oh, sorry. Yeah, I put 2. I pressed 2 times. So it becomes 6. So it extends 1. Yeah, it append 1. It append 1. And the size is growing. The issue would be how you will increase the array. There are two strategies. The first strategy is to increase the size by a constant. Or you can increase with doubling strategy. The doubling strategy means you can just make double. So if I have 4 at this moment, I will make it double. Another 4. So let's see. If I have this algorithm, add on object O, if T equals to S dot length minus 1, then A will be the new array of size n, and we will do for every of the element in this array, and put it on this new array with the size n. So every of the element in A will be shifted into the S. And yeah, we will do for all the things. And at the end of this S, we will add the object O. So this is the mechanism if you want to add one object. We need to compare this kind of strategy. We compare the incremental strategy and the doubling strategy by analyzing the total time. We call this is Tn, the total time, needed to perform a series of n at at O operation. So if I have a series of n and I'm making a new object, I'm making a new object, I'm making a new object, then how many total times do I need? So we assume that we start with an empty stack represented by an array of size 1. So the array will start with size 1. And then if we increase, then it means we have 2. If we increase with incremental, we have 3. If we increase with incremental, we have 4. We call amortized time of an add operation as the average time taken by an add over the series of operation. Okay, so we call this is amortized time by making this. So the number of operation, the time that you want to add n elements, and you want to divide by n. So we call this is the amortized time. Okay, so the amortized time is the total element or the total time divided by the number of elements that you want to add. So it is the average time. We call this is amortized time. Let's see if it is an incremental strategy. If it is an incremental strategy, now let's suppose I have the array K and I can just replace K equals to N divided by C. C is a constant. You can say like, yeah, C, if C equals to 1, then you will have 1 element. If C equals to 2, then you want to add 2 elements. So the total time, Tn, of a series of n add operation is proportionally to this one. I have n, okay, and then I would like to add C, constant. I would like to add C. And then if I add again, I would like to have 2C. If I add again, then I have 3C. If I add again, I have 4C. If I add again, in particular time, I have KC. So this series, we can simplify into C multiplied by 1 plus 2 plus 3 plus 4 until plus K. And yeah, this kind of arithmetic series, we can simplify it into this one. So last time we learned about how we can do the summation. If we want to do the summation from a linear number, yeah, 1 plus 2 plus 3 plus 4. Okay, then it is yeah, you can get 3 plus 7, it is 10. Okay. This will be the same with the 4. This is the number that we have plus n plus 1 multiply n plus 1, which is 4 plus 1. So 4 multiplied by 5 divided by 2. Okay. Then the result will be 10. It is 10 operation. So the idea is the same with this one. K multiplied by k plus 1 divided by 2. Okay. Because we already have this n plus c, which is a constant, and it is a series, k multiplied by k plus 1 divided by 2. Now, what you can see from this formula, it becomes n plus c k power of 2. This is the worst case. K multiplied by k plus 1. Then it can be like, you can say k power of 2 plus k. Okay. And in the big O analysis, we already know that we will take only the higher order. And we can just remove. We can just drop the lower order. At the end, we will have n plus k power of 2. Because we have n plus k power of 2, we have k power of 2, then this is the worst case, and we can say this is On power of 2. The amortized time of an add operation is On. So what is the amortized time? We have the Tn divided by n. In this case, the Tn is n power of 2 divided by n. Then the result will be n. So the average time for the incremental strategy is n time. This is the average. But when we have the doubling strategy, we replace the k with log base 2 n time. Why? Why we can change with this log base 2 n times? Let's see. Whenever we have the doubling strategy, let's say if I have the first is only one element, then I will add 1. And the second, I have 2 elements, then I will add 2. Maybe after that one, I have 4 elements. And then after that, I have 8 elements. So every of this element will be added according to the power of 2. 2 power of a particular number, k. 2 power of 0, oh sorry, not 0, it's 1. 2 power of 1, 2. And then 2 power of 2, 4. 2 power of 3, 8. 2 power of 4, 16, and so on. Until we have 2 power of k, and this is the geometric series. And in the geometric series, we can have this computational formula to get the summation. And yeah, with this formula, yeah, n plus 3, n plus 2 power of k plus 1 minus 1. Yeah, at the end, you can just make a very simple formula into the 3n minus 1. If we have this 3n, of course, it is only On. What is the amortized time? The amortized time is the Tn divided by n. What is Tn? The Tn is n. N divided by n, then it is 1. So the average time when we do with the doubling strategy is constant, because we will double the space and then we can just add the values. So this is until 2 power of k. Okay, so it is until k times. In the long run, the doubling strategy is better in the performance. If you have only 1 or if you have only 2, I think it's the same. But if you have until k, so in the worst case and in the amortized time perspective, doubling strategy will be better. Okay. I put this one into the Jupyter notebook. You can build your own array. So this array actually is the same with the array that you can use in Python. The class dynamic array, you have the constructor. So you can start with 0, and then the first array has only one size. And then you will make this one as the make array with the self capacity. So make array is a defined function here. As I mentioned to you last time, length is a predefined function in Python. Get item is predefined function in Python. So yeah, in the length you can get only the length of the array, and then get item you can get the index. Okay, so what is the element at a particular index? In this case, I want to define with k. So if the index is invalid, then we will give the index error. What if you want to append? Okay, so this is the append function. You can change according to your preference, but this one is using the doubling strategy. So for every time we want to append, the size of the array will be double. As we know before, the doubling strategy is more efficient in terms of the amortized time. So it is good for the long run. It is good when you have a lot of data that you want to insert into the array. So this is the function. If n is equal to the capacity, then resize the capacity to double. And then you will put the object into the particular index of n, and the n will be added by 1. So the resize function will be something like this one. You will make B as a new kind of array, and then for every of the element in the A, you will move it into B. So let's just put all the B into the A, which is the new one with a bigger capacity, and the capacity will be set with a new capacity. So make array means, yeah, you want to copy. So this is a kind of copy array function. So you can just use the object and you put in new variable. This is the insert and this is the remove. So for the insert, you will insert one element after you already have the new array with new capacity. If you remove, you want to remove the element in a particular index. In this case, we want to remove a particular value. When it is matched, then you will remove it. And after you remove it, you will like shifting all the elements according to the array capacity. Okay, I think I can just mention about this one, about the array, and we will continue next class with the additional things, stack and queue.